Welcome to Linked Data Engineering. This is lecture number 5, Linked Data Mashups and Applications. And in this part of the lecture, we want to write a little program and make use of linked data. Okay, let's start with a general setting. How should linked data-driven web applications be built? So usually you require a specific set of components. Often you require a local RDF score, for example, to cache your results, or also using this as a permanent storage. But it's not necessary to keep this in a way. It could also be an in-memory RDF storage, of course. Then you must implement some logic. Of course, this is the controller, and you need a user interface, which implements the business logic and which is not a linked open data specific part. What is important are these two components here called data integrator and data republisher. First of all, you need something like a data integration component. So usually you want to make use of data that is available somewhere out there in the linked open data cloud, and therefore you have to integrate it with your own data, or you're accessing several specific components from the linked open data cloud and you have to integrate them. Therefore you need this integration component. Besides the direct access, there is also the possibility to look up data at some semantic indexer, like a semantic web search engine, which then relays you to some kind of linked open data set. And on the other hand, so when your logic somehow has processed the data, made use of the available linked open data, what you do is then you try to republish your data, and therefore you need the data republishing or data publishing component, which in the end takes care of writing back your data into the web of data, into the linked open data cloud. So this is the general architecture of web applications that make use of linked open data. And of course, you can look this up in more detail via the link I have given you here below. Okay, what do we need? How do we get RDF and Sparkle into our programs? Of course, there are lots of different programming languages, and of course there are also suitable libraries for almost all major programming languages. Starting here, for example, with the library for JavaScript or for PHP, or here the .NET RDF library for C#, or there is Java library from Jenna/Arc, or Sesame, it's also for Java. We want to use, just for the sake of simplicity, a Python implementation, a Python library. It's called the Sparkle wrapper. I have chosen this because this has the least effort to write a linked data application. And Python is a rather simple language, so if you know Java or anything like that, you are also able to write a Python program because this is pretty similar. And it's really simple, you will see that. So we will make use of this Sparkle wrapper. And you see here all the download links where you really can get access to this open source or freely available libraries for the usage of RDF or Sparkle. So the easiest way is to make use of this Sparkle library. And of course, what we want to do, if we want to access linked data, we access the most prominent linked data resource, which is DBpedia, and we are using for this the DBpedia Sparkle endpoint, also just for simplicity, and all the data we want to analyze and to access lies out there. So next thing is we have to think of a simple example. So how should it look like? My idea would be the following. We build a simple application that looks for today's birthdays of famous people, and I have chosen authors. I know in some other parts of the lecture we have talked about Game of Thrones, or we have talked about astronauts. This time we talk about authors. So the task will be, we want to create a list of authors whose birthday is today. And this of course should also work tomorrow. So we do not want to fix the day, we simply want the day you start the program, it runs, it produces a list of today's birthdays of famous authors, together with some additional information about the author, like for example, when exactly is the author born, so in which year, and possibly a short description, because you possibly do not know all the authors that are present in DBpedia, so therefore a nice description would be great. So we will see, we will also take a picture of so a thumbnail for the author, which is also a nice feature that DBpedia provides. And to represent this then, we create a simple local web page. So we make an HTML encoding, which then can be loaded as a file into our browser, and we can display it simply. And we use for this the Python programming language and the Sparkle wrapper library for Python. So first of all, what we have to do, we have to take a look for our data. We have to analyze the data in a manual way. So we want to display information about authors, therefore just look for authors in your data source, which is DBpedia. So I have chosen a representative example of an author. So here it's, for example, Alexandre Dumas, and we simply look it up in DBpedia. So I click here on DBpedia and we will look up this page in DBpedia. So here it is, and you see, we see all the information, and we said, okay, what do we need? We need the birth year. So let's have a look. What do we have here? We have a birth date. That's quite nice. And you see here the birth date is formatted according to this XML schema definition date standard. So this is the year 1802. Then we have the month with its July, and then we have the day, which is the 28th. So for our application, of course, this part here, the month and the day, would be for importance to decide whether this author has today his birthday or not. And what we want to display is this part of the date, which is the year. So we need somehow the birth date. That is clear. Okay, what else do we need? Possibly we need the name of the author and possibly also some information about the author. So let's have a look where there is some suitable information that we could use. You see here RDFS comment. Of course, this is interesting, and we see here short information about the author. One is here in German, one is in English, and we can of course decide here only to take the English one. So this would be interesting information. A picture, is there a picture on the page somewhere hidden? So we can look for a JPEG here somewhere, and you see, DBO thumbnail provides a JPEG. So here it's JPEG. Simply click on that, then you will see whether it's a JPEG or not. And you see here that's a pretty nice picture of Alexandre Dumas. And of course, we could use this for our display. Okay, let's get back to our task. So first thing, look at your data and try to think of something you want to display and you need. So we do this manual data analysis via Sparkle. What do we need? So what kind of entities are we looking for? We are looking for authors. So how do we know that somebody is an author? We have already seen that. We look at the RDF type information in DBpedia, and we have to look up that this is of type DBO writer. Then we know this must be some kind of author. So this is the first graph pattern that we need in Sparkle. So what information do we want to provide? First of all, we want to provide the birth date. So simply we have another graph pattern where we say, okay, DBO birthday should be our variable birth date. Then next one, we need a name. So we can use, for example, RDFS label. And we have seen in RDFS comment, there is some description that we can also use. What else? Okay, thumbnail. Probably not all the authors provide a thumbnail. So therefore we will make this optional and we'll say, okay, author DBO thumbnail, and this will be then the URI of our thumbnail. This is information we want to display. And do we want to filter it somewhere? Yeah, sure, of course. For the name as well as for the description, simply use the English description. Otherwise, we would have lots of different results we don't want to have. So you also can choose German or French or any other language you want to have and which DBpedia would provide. So we have here the language filters. We have learned about this in our Sparkle lesson. And of course, we should look somehow to these authors whose birthday is to date. So the recording date of this lecture that you see here is the 4th of November. How can I look for authors who are born on the 4th of November? It's quite simple. So I have here the birth date. I convert the birth date into a string. And I say, okay, I start at position 6 and take the substring of it, which then is the month and the day. You remember that? And I say this should be the same as 11-04, which means November 04. This would then, in the end, filter out all authors whose birth date is on the 4th of November. But tomorrow it's the 5th of November. Therefore, there are more sophisticated methods also provided already in SPARQL to manage this. You might not know that, but the SPARQL endpoint of DBpedia, it's an OpenLink Virtuoso SPARQL server. This SPARQL endpoint has some built-in functions. They are in a specific namespace, which is called BIF for built-in function. And this provides the current date, which is the date of today. And you do this like this highlighted part here. And you simply can say, okay, this one should match the current date. So this part should match the substring of the birth date I have looked up before. And this, of course, every day would be another date. And if I compare to the current date, then I will select authors whose birthday is on any day on which I'll let this program run. So this is a bit sophisticated, and of course you could not know this in advance, but this is a nice feature of a SPARQL endpoint that we will make use here, and this comes quite handy. Okay, so I have put together the SPARQL query here, and we can take a look at it right on, if you click on the link. And let's have a look on that. So I declare several namespaces, RDF, DBO, RDFS, DC. DC I don't need here, so I can simply put it away. And okay, what do I select? I select the birth date. And of course, I only want to have distinct, so only one per, individual author information per author. So I put the distinct to avoid duplicates. Then I want to have the birth date. I want to have a thumbnail. I want to have the author, the name of the author, the description of the author. So, and now come all the patterns I have defined beforehand. So first one, author should be of type writer. Then the birth date I select here. Here I select the RDFS label, which is the name, and here the RDFS comment, which is my description. Then I have some filter criteria. First one, language of the name should be English, language of the description should be English, and then here, that's the other thing, I say, okay, we might realize that not all the authors have a perfect birth date, which is correctly formatted according to the XML date standard. So therefore, we say, okay, in this information, sometimes there is only a year given, for example, and then we cannot say whether the birthday is to date or not to date. We say there should be given more than 6 characters to make sure that there is some date information, not only the year, but also the month and also the day. So this is this part. I say the length of the string, if I convert birthday to a string, should be larger than 6. And then I have here the birth date. I convert it again to a string. I look at position 6. Everything that comes behind is then usually the month and the day. And this should be the same as the same part of the built-in function current date. Also here starting at the 6th position. So this should be equal. And then optionally, I also want to select the thumbnail. And then of course I want to order all these results according to the birth date. So the oldest one first and then the newest one last. So I run the query. And you see here the birthdays start with 1658 and they stop at 1986. And you see here, these are the authors. So these are the links to the authors. And then here are the author names in English. And then you see here, this is the description. Quite nice. Okay, but I want to make use of this now in a program. So next step I want to take is simply write a program. So for the program, I've told you we do this in Python. So if you also want to try this at home, you have to have Python installed on your computer. You can download it. Of course, it's free and it's available for almost all available operating systems. And of course, you should download the SPARQL wrapper for Python. Down there you see what comes with the SPARQL wrapper for Python if I extract the archive that is delivered or downloaded from the web. And you can see here several things. You can read the README file, and one thing important, there is a folder which is called scripts, and in the scripts folders, they're usually for this Python wrapper, there are all the programs. So to continue, we go here to the terminal window, and you see here, this is again, I show you what's in the directory, and we can go to the scripts and can look up what's there in the scripts, and there is my program example_o2.python. It will not be there in your distribution because I have written this, and now we can do this together, or you can download this program then also from our website and you can experiment with it. Okay, I put this now into an editor. I use here Sublime, and I have here prepared this file in my editor. It's a short file. You see here it's only a short program. And we go through the program point by point, and I will explain you what is in there. And you will see it's pretty simple. Okay. So we start first, we need URLs, so therefore I import here a URL library in Python, and I have to deal with dates and time, so therefore I also import date time, and of course I have to import here the SPARQL wrapper with all the language formats that are available. Okay, then next thing I have to do here is simply I say, okay, I use the SPARQL wrapper and I have to define the SPARQL endpoint. And I say simply here I define a construct or a clause, it's called SPARQL, and this is then SPARQL wrapper, and I give here the SPARQL endpoint that should be accessed, and this is the DBpedia SPARQL endpoint. Next, I create the query. So I have a method here in my SPARQL class which is called setQuery, and then here I can write the entire query right from my SPARQL endpoint window from DBpedia. I can copy it directly here. Just think of it in Python to copy this and to also make a one-to-one translation of what you see here into Python. You have to, so to take everything verbosely, you have to use 3 double quotes, then comes the entire query, and then 3 double quotes again to close it. Okay, and this of course has to be written in parentheses for it's the input for this method setQuery. So this is my SPARQL query. Next one, I set the return format. I say I want to have this in JSON because then with JSON I do further processing in this program. And then I here simply process my SPARQL query. I say results will be SPARQL query, and simply I convert it then to the format JSON. So this then is the execution of the SPARQL query. Next thing, I start to create my HTML output. So first one, I write of course HTML. I have a header file which has the name literary birthdays of today. This is the header file, and then I go on. Next thing I do is I have to extract here a date. So from this date time format, another Python internal that we use here. And then I say, okay, I start the body of my HTML page and I say, now come the literary birthdays of today. And here comes again datum, which is the date of today. And I extract here simply of this date time today, which is the function I call here, the day of today. And simply I write it then here, literary birthday of, and then comes the date of today. And for this, I provide here in the print method, I say format datum, and this is this one, which is provided at exactly this place where you see here the curly braces. Okay, then I start a simple unordered list in HTML. You see this here. And then I step through my result list. And this is, of course, also something which is available in Python. You have here these interesting arrays, so where you have 2 dimensions, results and bindings, which are connected here somehow. And of course, I step through the results here and I say if author is in the results, then I first use author. Author was, the URI from the entity of the author, so the resource page. And what I want to do in my web page is I want to provide a link to the author, but not in DBpedia, but to Wikipedia. This is also quite simple. So I take here the author information from my results list, and I say here the wiki URL is simply this prefix from Wikipedia. And then I take the result, which goes to author, and here I have the value of the result, which then is the URI, and I encode it here in ASCII, and I split it here, and I take simply everything which comes after the last slash. And this I add to this prefix, and then I have the Wikipedia prefix. Quite simple. Try it out, think about it, it's quite simple. Otherwise, if there is in this result set no author information, use none. So then we don't have any URL here. If the name information is in the result, then of course we simply put it here as the variable name, and we use here name, the value according that is mapped to name here in the result set. If it's not available, then of course the name is also empty and it will be none. So it's the string none written in capital letters, and we will see if there has been a name provided or not. Here is then the same with the birth date. I take date as the value that has been mapped to birth date, and I simply also use this here in that case as an ASCII value. And if it's not available, again the same procedure. And I do the same here with the description, and I do the same here with the thumbnail. The thumbnail was optional, so there's potentially lots of authors which don't have a thumbnail, which don't have a picture, so therefore I have to think of something else, and I have looked up in Wikipedia Commons a picture or a small image of a question mark when I don't have a picture, and this then will be displayed exactly instead of the real thumbnail. So this will be then a question mark, and this is the URI of that question mark. So we are almost done. Next thing what I do here is, again, I take the date from my result, and what I do here is I want to put it in the following format: year, month, and day. And then I have the print line here. So for my list that is really printed in this HTML representation, I put in here first, this is the year information from the date. So I put here the year, that's the first thing. And the second thing, I put here an image, so HTML image, and I say the source of the image is, and then there comes the URI of that image. So this will be then here what I have here described in pic in this variable. And the interesting thing is this is a dynamic URL. There I can substitute, for example, the size of the image that is transferred back. Usually it's here as a thumbnail, it has size 300. I decide to take a smaller one, which is only of size 60. So the height of the image will be 60 pixels. And of course I emphasize this because I give a parameter here again to the image tag, and I say the height will be only 60 pixels. And then I give a link to the Wikipedia page, so an A tag, and I give an href, and here comes the URI, which is here the wiki URI, and then I give next the name, that is that here, and next comes the description, and then I end the list, and then simply, okay, this was the list, I close the body tag and I close the HTML tag, and that's it. So let's try it out. And of course, you should study it deeper, and of course feel free to change it and do your own experiments based on exactly that file. Okay, let's go back here. You see here example_2.python, and now to run this I have to say Python, and I have to say example02 Python. I simply run this, and you see here the result will be some HTML code. So these are simple lists of HTML. And to make use of it, I will put this, of course, into some file, which I call authorstoday.html. So this will be now an HTML file right here in that directory, which I can then access with my browser, and then I can see the content. So I run it again. I have run it. Now I go to my browser. I'm in the browser. I have a new window. Here you see the URL of my file system. It's in SPARQL wrapper, scripts, authors today I called it. Now I load it. And you see there is a list of literary birthdays of Friday, November 4. And this is also the recording date of exactly this lecture. And as you see here, it starts at 1658, and the first picture cannot be loaded. Sometimes this happened. And you see then, this is some kind of author. This is the name, Sulkan Saba Orbeliani, never heard of them. And there is then some explanation. So this is a prince, and he was a Georgian writer and diplomat. And if you want to have more information about that guy, simply click on it, and then you will be on the according Wikipedia page. We can go back, of course. So let's see if we find somebody more known. No idea, sorry, today. There are many authors I have never heard of. Maybe you find someone you know on another date. So let's look at the younger authors. I also don't know the younger authors, I'm sorry. So simply let's look at the last one. Who is this? Christine Cast, born 1986. I click on that, and then you see, interesting author. Okay, so House of Night, never heard of that. Should be a piece of literature written by this author. So, this is the program. Feel free to change it and to start over and write your own programs with it. So this is really quite simple. Okay, and we go back here to the presentation. So we've already made it. So again, here is a picture of the editor and the program that we have just talked about, and of course a picture of the result that we have achieved with it. Of course, there are other application programming languages. Java is one of the most prominent and most widely distributed languages. And for example, if you want to do the same thing we did just now in Java, the only thing, of course, if you use here, for example, this JennaRQ library, let's have a look on that. Of course, you have to import that library, and then what you do here in Java is you define two strings. First is the service endpoint, which is the SPARQL endpoint. Second one here, query, which will contain the entire query string, and then you define a query execution E, which is a query execution factory, and you have here the method SPARQL service, which specifies the service endpoint and the query. And then here you say E exec select, which means you execute the SPARQL query for exactly that object, and the result then will be here in results, and then you simply go through all the results list that has been created here, and you look at your query solutions, and then you look what is inside the query solution S, and simply plug it piece by piece, take the symbol variables or the single values that are then in one result set from the SPARQL, or in one result row of the SPARQL query. So it's basically the same. It's quite simple, and also for the other programming languages it works in some really similar way. It's quite simple, and you should, of course, you are invited to try it out. So far for linked data programming. The next thing we want to do is we want to use linked data and create some interesting visualizations out of it to understand the data much better.